Near the St. John's Bridge, crews prepare hundreds of tons of marine construction gear. Without it, work on the interceptor cannot begin. But the first obstacle is getting these puzzle pieces to the job site.
It's a complex project. There are a lot of moving parts. The design was complex. Certainly the installation of those parts is just as complex, if not more.
I would say that this is a detail-oriented project. There's lots of small details from one end to the other. Planning's what keeps you out of trouble. The little details are what gets you in trouble.
Mike Johns is the detail man for Advanced American Construction, lead contractor for the interceptor.
My job is to make sure my guys do their job. I got 2 phones and 1 radio, and I think maybe that'll be enough.
His crews must now deploy the bulky equipment onto a nearly inaccessible Oswego Lake.
As you can see around here, we don't have any access. The hardest part of doing the work is getting started and set up. When we launch the barges, we got about a foot of clearance to get a barge in the water. We're stuck on city streets where we can't park. Getting here is half the battle.
8 barges must be pinned together, then outfitted for specialized tasks, one piece at a time.
How much more? Hasn't moved yet.
It's a 175-ton crane. We broke it in half in order to get it in here. If you break the shaft, the crane's not going to work. It's a balancing act between perfectly plumb, coming down the center shaft. Sounds like it just went in. There you go.
Half an hour away, in a sophisticated 55,000 square foot fabrication plant, another piece of the puzzle is coming together: high-tech manholes.
This is a state-of-the-art facility. My name is Nathan Marks. We're at Marks Brothers Incorporated, which is our family business. There's a fair amount that went into the design of these that typically doesn't go into the standard manholes that you may drive over with your car in the street.
Each of the 7 3-ton capsules must resist external and internal pressure, corrosion, even earthquakes.
Pretty much every piece of metal on that manhole was laser cut to within plus or minus 5/1000ths of an inch.
It's an 800-hour process to produce just one of these.
This is built to last.
Back on site, the wet work begins.
Today we're here at the beginning phases of installing our ground anchors. Because the pipeline floats, these are the anchors that will tether it to the bottom. And the soil conditions in the bottom of this lake are unique. There's a lot of cobbles and muds and sands and rock and basalt, and basically we're trying to get into the hard rock.
In some places, that means drilling through 200 feet of material.
Its complexity is probably a little more intense than a lot of our projects, and accuracy with which we have to locate and bore these anchors into place, it's difficult, but it's all doable. I'm Jerry Jensen with Jensen Drilling Company.
Over the next 4 months, Jerry's 8-person crew must install 440 anchors, one every 25 feet along a predetermined curve through the lake. With the help of satellite data, they locate the barge and drills within a half-inch of their targets.
We're guiding this whole barge that we're on now by GPS. Now this outline here is the drill barge itself that we're setting on, and then the anchors that we're going to be drilling.
Good there.
Each drill has 2 multi-purpose heads moving inside a casing.
This is a bit that evacuates the materials up through the center of the casing and makes the hole advance. The casing holds the hole from caving.
25 even. 25.75.
A geologist tracks progress as drillers search for bedrock.
The cuttings here are gravel. When we see that we have all chips and they're all angular and not rounded shape, we'll know we're into basalt.
Since every hole varies in depth, workers customize the length of each corrosion-resistant anchor. As anchor rods feed into the casing and down the hole, a grout specialist prepares his batter.
You got to use your mind's eye to try to anticipate what you're into when you're underground drilling in a borehole. And it's kind of the same thing underwater.
The drill crew advances the casing through water, mud, and gravels, then lowers the anchor through the casing into its design location. Grout locks it in place to bedrock with vertical precision 2 feet above mudline. The anchor's ready for later connection to cables that will hold down the buoyant pipeline.
And after 72 hours of set time, we pull on that anchor to different increments and see how it reacts up to 47,000 pounds. And if it passes that criteria for that jacking, it's a done deal, the anchor's complete.
Closer to shore, teams install corrosion-protected steel piles to support the pipeline in shallow water.
We have two different operations going on. We're vibrating pile into the lake with a vibratory hammer, or we're drilling into the bedrock with a down-the-hole hammer. Piles are 40 to 150 feet in length, 18-inch in diameter, and in the end they're grouted in to the bedrock. It's a neat system, but it's complicated.
It's not always typical in construction projects that the contractor is being as careful as the engineer would like. That's a high standard to meet, and so far they're doing it.
Coming up, fusing and deploying the pipeline.